You're about to watch this globular springtail jump and spin faster than any other animal on Earth. Ready? I was planning to film this video in the lab, but now, like a lot of us, I'm working from home. But I'm also using this opportunity to work with a different camera person.
You look like a pirate.
So I hope this video ends up sounding and looking okay. So a few months ago, I wasn't even 100% sure what a springtail was, but then they showed up in huge numbers here on the lid of my trash can. After a rain, they'd climb out of the mulch and hang out here on the lid. They're called springtails because they use a tail-like appendage to spring themselves away from danger. So I brought them back to the lab and started filming them, and now I'm proud to say that part of my research is on trash can springtails. So, for a start, we've been filming a bunch of jumps in high speed and tracking their movements frame by frame. Filmed about 50 individuals so far, and the data we're getting back is incredible. Here's the coolest part. When that springtail took off, it was spinning at a rate of 374 flips per second. That's equivalent to 22,440 rotations per minute. To put that in perspective, the main rotor of a helicopter spins from 250 to 600 RPMs, while the max RPM of most race car engines range from 7,000 to 15,000. So these tiny little springtails, as far as I can tell, might be the fastest spinning animals on Earth. These jumps and spins are all powered by a spring-loaded tail tucked underneath their body called a furca. When it's released, the underbelly of the springtail folds open and throws the tail down and around the body. The details of which parts of the body make up the energy-soaring spring and how the tail is released at the start of the jump are mostly unstudied and unknown. But so far, we've recorded an average upwards acceleration of around 700 meters per second squared, which is right between that of a leafhopper and a flea. Springtail jumps are incredible when you consider what they're doing relative to how small their bodies are. For scale, here's one next to the tip of a toothpick. It's only about 1.5 millimeters long and 1 millimeter tall. A more or less vertical jump looks like this. At the apex of this jump, the springtail is 48 millimeters off the ground, and its rate of spin has fallen from 255 to 150 flips per second. It'll continue slowing its spin rate as it falls and bounces off the ground. For a sense of how fast all this happens, here's that same exact jump, filmed from above and played back in real time. Right now, all we're doing is answering what questions, trying to describe what these animals do when they jump. But there's a lot of really interesting why questions, like why are they spinning so fast in the first place, and is it even on purpose? One really interesting idea is that they might be taking advantage of the Magnus effect. You've probably seen videos of this before. It's where the spin of an object moving through air creates pressure differences and a force that alters the path of the object. I'm not sure if there's been any example of an animal using the Magnus effect, but these springtails might be one. It'd be a cool thing to model and try to figure out. So for now, that's the status of our trash can springtail project, and thanks for watching this video. Springtails are some of the most abundant soil arthropods on Earth, so if you want to find some yourself, they're probably right outside wherever you are. Just look for a nice thick layer of leaf litter like this, and sort through it, and if it's moist enough, you'll find them right in the leaf litter or in the soil.